Alright, let's grade this. We'll talk about it later. Alright, I want to hear this story. Okay. So, what happens around a double asymptote? So, you can draw it. So basically we have the two sides going the same way. Either both up or both down. Okay. And so you might say they go the same direction, something like that. And again, same direction isn't really a very specific description of what happens. It's just supposed to remind you of the sort of the basic property. What about a triple asymptote? 3 is an odd number, by the way. So odd means they're going opposite directions. Okay. There you go. Alright. So number 2, equation of a rational function with a triple asymptote. Okay. So basically an asymptote goes on the bottom. And if you want an asymptote at 11, then you do x minus 11. Because 11 is what you would plug in to get 0. And it's triple, so it's got an exponent of 3. Then a double root at 0, or double 0 at negative 8. Good at reading. So 0 means it's going to be on the top. At negative 8 means you're going to have x plus 8. And then a double 0 means it happens twice. And then a single asymptote at 0. So what do I put for a root or asymptote at 0? Yeah, just the factor x. Or you could put x minus 0 if you really want to. But you should. Is that it? Yep. I think we got them all. Okay. Number 3. Here we want to list the zeros and describe the behavior of each. That means we need to do a little bit of factoring, specifically for the top. So zeros are on top of the function. If the top of the fraction is 0, the fraction is 0. So we need to factor the top. First, they've got something in common. If we factor that out, that'll make life a lot easier. So 3x in common, then we can factor out that. And we've got x squared minus 6x plus 9. Were you all able to get that to factor? So x minus 3, and then x minus 3 again, or x minus 3 squared, right? Yeah, okay. So what are my zeros? So I've got x equals 0 right there. And here I have x equals 3. And what kind of behavior would I see at this one? It's going to cross, because it's raised to the first power. What kind of behavior would I see at this one? It's going to bounce, because it's raised to the second power. Like a parabola. Okay, and then we'll do the same thing for the bottom. So it's already partially factored, but we need to try and factor this quadratic part that's left over right here. So how does this factor? It's okay, you can tell me. Did you figure it? You got it factor. Alright, are we all good? Okay. So let's say you said x plus 1 times x plus 1, because that's how it factors. So I've got x minus 5, and then that's x plus 1 squared. So we've got a single asymptote right here at x equals 5. And what kind of behavior happens at a single asymptote? Yeah, opposite behavior. And we also have a double asymptote at negative 1. The behavior there, the two sides will be going the same direction. Right. So, there's the front page. Questions so far? Yes, ma'am. Mm-hmm. Okay. Back page. So here we want to do some long division. I seem to have not left enough room to do that on the paper. So let me get some scratch paper. Okay. So x squared minus 21x minus 45 goes outside the house. And 3x cubed minus 47x squared plus 96x minus 180 goes inside the house. So to do the long division, we first want to check how many times x squared goes into 3x cubed. And that's 3x times. Then we're going to take that and multiply. So we'll distribute it 3x cubed minus 63x squared, and then minus 120 and 135x. Then we're going to subtract that. So that changes all the signs, so we get nothing. And then negative 47 plus 63, so that's 16x squared. And then 96 plus 135 would be 231, right? So we'll bring down to 180. And now we do everything all over again. So how many times does x squared go into 16x squared? Positive 16 times. So then we're going to take that 16, multiply it by all this stuff, and subtract. What's that? 324. Help me out here, people with calculators. Okay. So it's 320 and 15, right? 336. Okay. And then 16 times 45. Okay. Negative 720. Now we're going to subtract that. So those cancel. Here we'll add, so that's 765. Well, I was doing it backwards. Yeah, 567. And then we'll add here, except that one's negative, so we'll subtract. So 0. So 540. Okay. And it'll be positive. Right. And that's our remainder. Because x squared will not go into 567x. Because there are more x's up here than there are. So we've got our quotient plus the remainder divided by the divisor. And so this function is exactly the same as this function right here. They are equal to each other. But what this does is it separates this into the part that matters for the end behavior. So the end behavior is going to be controlled by this part of the function right here, 3x plus 16. Whatever 3x plus 16 does, which is that, because it's a line with positive slope. That's what the ends of the function are. Which brings us to the next question. Does this function have a slant or a horizontal asymptote? Yeah. Well, when we divided, we got a slanted line, right? A line with a slope of 3. So it's slanted. And so to describe the end behavior, there are a couple of ways we could answer this. So it's going to have the same end behavior as 3x plus 16. So the left side is going down and the right side is going up. So that's one thing you could say. You could also say as x approaches infinity. So let me do it in the same order I usually do it. As x approaches negative infinity, that means on the left, then f of x would be approaching what? Yeah, negative infinity. So on the left, it's pointing towards negative infinity. And as x approaches positive infinity, so in other words, the right, then the y value approaches positive infinity. So there's the notation that we used on the last test. Question? Yeah, I think that's a good description. So probably what I'll ask on like a future test, like a final, is like I'll put these blanks and have you fill them in, something like that. Just because that's the notation we used before, and it's a good precursor to calculus notation. And this is pre-calculus. Okay. Number 7. Describe the end behavior of this function. Now, we don't actually have to do the entire long division process to figure out the end behavior. Really, we just need the first step. And so for the first step, we need to know what the leading term of the top is and the leading term of the bottom. So if I multiply all of the first terms of the factors together on top, what do I get? Yeah, there are 6 x's. One of them has a 3 in front of it, so 3x to the 6th. So it would be 3x to the 6th plus some stuff. What stuff? I don't care. And then I'm going to do the same thing on the bottom. So x cubed times x times x times x. That's just 1x to the 6th. Plus some other stuff. What other stuff? I still don't care. And then to figure out what the end behavior is doing, I want to know what kind of function do I get when I do the long division. So x to the 6th plus some other stuff goes into 3x to the 6th plus some other stuff. How many times? Yeah, 3 times. And so just from that one thing, I know what kind of end behavior I have because I should know what the function y equals 3 looks like. What does it look like? It's just like a line. Everybody's error showing it. I'll do that for the camera too. Just like that. It's a horizontal line. Specifically at y equals 3. So in other words, we have a horizontal asymptote. And the equation is y equals 3. Right? That's the end of the quotient. You wouldn't go on and find another term because there are no x's. Okay, so we've got a horizontal asymptote of y equals 3. So what's happening on each end? Well, it's not going to positive infinity or negative infinity. Our graph is actually going to approach the value 3. So if I asked you, say, what happens as x approaches negative infinity, what is the y value approaching? In this case, you wouldn't say positive or negative infinity. You'd say the y value is approaching 3. I think it's closer and closer and closer to 3. And that's on both ends. So on the right, on the far right, the y value is also approaching 3. Okay. So if we say something about there being a horizontal asymptote at y equals 3, as long as you know what it looks like, which is what we'll find out here. So number 8, we want to plot this function. So there's a lot of stuff going on here. Let's take it one thing at a time. We'll plot all the zeros. So we've got zeros where? Positive 3, right? Okay. And it's going to bounce. Then at negative 7, it's going to squiggle. Yep. Yep. And then 3x to the 4th, 3x plus 4. If I set that factor equal to 0, what do I get for x? Yeah, negative 4/3, which is a little bit past 1, right? That's 1 1/3. And it's going to cross there. Okay, so I've got 3 zeros. I also have 3 asymptotes. X cubed on the bottom. What does that mean? Yeah, and vertical asymptote at 0. And x minus 5 on the bottom. Oh yeah, and that's opposite behavior because it's an odd exponent. X minus 5 on the bottom. That's an asymptote at x equals 5. And it's to the first power, which is an odd number, so it's got opposite behavior. And then we have x plus 8 squared, which is an even power, It's an asymptote at -8. Okay. And so because it has an even power, the two sides of it are going the same direction. Alright. So now all we need to do, oh yeah, one other thing, what else should I plot before I start graphing stuff? Yeah, the other asymptote, the horizontal one, at y equals 3. And so remember, the horizontal asymptote doesn't matter in here. All it matters, the only thing that concerns the horizontal asymptote is what happens on the end. So that's the end behavior. So I know that on each end, it needs to approach the horizontal asymptote as it goes off towards infinity. It can cross it. It doesn't matter at all. It just matters on the ends. Okay. So we've got all that stuff. Now I want to actually graph the the curve itself, the function itself. So let's grab a calculator. It'll show us some stuff, but because we're good at algebra, we'll know some other stuff. Yes? Possibly. Yeah. Okay, thanks. Yeah, so that should be a -1/3 right there. Okay, thank you. Alright. This will only take a minute. Remember to put an extra set of parentheses around the top and the bottom to help your calculator out. I'm going to go ahead and graph the horizontal aspect. Alright, so there's my graph. This actually gave you a pretty nice graph as far as these go. Did it look as good on the yellow calculator? No, not quite. Pixels and lines. That's like it just merges with the x-axis for a while right here. You can't see it, and then it pops straight up. Yeah. Okay. So this is a pretty good graph that we have here. So we'll still work with it. All right. So first off, let's just work from left to right. So you can see this little piece of the graph out here on the left goes like this. And you might also notice it crosses the horizontal asymptote. So what is it going to do? Is it going to go like, is it going to cross it and go down to -infinity? Off to the far left? Sure. Is that possible? What does our graph have to be approaching as it goes off to the far left? Yeah, it needs to be approaching the horizontal asymptote. So even though it crosses it, we know, that it turns around and it's got to approach that horizontal asymptote as it goes off to the left, because that's what the horizontal asymptote means. So we'll draw that. We'll represent that. What happens in this next section? So we've got this asymptote with the same behavior right here. So it's going to start up top, and you can see that on the graph as well. The graph was nice to us this time. So it's going to come down from infinity. It crosses the horizontal asymptote. That's okay. It's going to squiggle at -7. And turn around and cross at -1/3 and go back up like that. I didn't draw it very well, but that's okay. And then it's going to skip over this asymptote, and when it does, it's going to change directions. So instead of going up, it's going to be pointing down. And it's going to come up here and bounce off of the x-axis, and then turn around and come back down. And then we know that on to the right of this, it has to switch directions. So instead of being down, it's starting from the top, and as it goes off to the side, it's going to approach that horizontal asymptote like that. So that's kind of the basic shape. So we want to take that's a kind of a hard question to answer. So basically, why? Like I don't have a good answer to that question. Why? How? So basically, we just know this from looking at the graph, right? This is what the graph shows us. Now, usually what'll happen, so like, most of the time when you have a horizontal